Reddy Dhanush. Now I will be explaining about the topic minimization of DFA. Generally, there are two methods for the minimization of DFA. I will be explaining about the partition method. Before going to the steps to be followed for minimization of DFA, first we will consider what is DFA. DFA stands for deterministic finite automata. Generally, it consists of finite number of states, and on giving an input, it goes to a single state, unlike a non-deterministic automata, which goes to multiple states on giving input. And DFA can be defined using five tuples. Those are set of states, inputs, start states, set of final states, and a transition function. DFA tells whether a given string is accepted or rejected. Now we will see why minimization is required for a given DFA. Because it increases the stability of the given mission, and as number of states will decrease, there will be faster execution, and there will be decreases in the space complexity. And in future, if we want to modify or debug, the process will make easy. Now, here is the basic example of minimization. Before minimization, this is the given DFA. It contains six states: Q0, Q1, Q2, Q3, Q4, Q5. But after minimization, it contains only three states. And if we take any string like 100, we can see this 100 is accepted by DFA before minimization and DFA after minimization. So we can say these two are equivalent. And now we will see the steps to be followed to minimize the given DFA. First step, we have to identify the states which are unreachable from the given initial state. And after identifying the unreachable states, we have to remove the unreachable states. And with the remaining states, we have to draw the transition table. And in step 3, we have to divide the states into two sets, set containing non-final states and set containing final states. And in step 4, we have to reduce these sets in each row such that the states in these sets will produce the output which will be in the same set in the previous row on giving the same input. And in step 5, we will see whether two rows are equal. If two rows are equal, we will stop the process, and the final row will be the final states in the final minimizer DFA. Now let us consider an example. In the given DFA, there are five states: Q0, Q1, Q2, Q3, and Q4. Now we can see that from initial state, that is Q0, all states are reachable. So there are no unreachable states here. So we will draw a transition table for all the states mentioned in the DFA, that is Q0 to Q4. And in step 3, we will divide the states into two sets, that is set of non-final states and set of final states. Here set of non-final states are Q0, Q1, Q2, and Q3, and set of final states is Q4. So in step 4, we will reduce each row such that in each row the set contains states which produce the same output on giving same input, but that output should be in the same set in the previous row. Let us consider here in P0 contains two sets, Q0, Q1, Q2, Q3, and another set contains Q4. Now, if we see the DFA, Q0 on getting in Q0, Q1 on getting the input A, it goes to states Q1, and Q0, Q1 on getting input B, it goes to states Q2 and Q3. Now we can see here Q1, Q2, Q3 all present in the same set in the previous row. So now in the next row also Q0 and Q1 will be in the same set. Now we will check for Q1 and Q2. Now we can see here Q1 and Q2 on getting input, it goes to the state Q1, and Q1 and Q1 and Q2 on getting input B goes to the state Q3 and Q2. So we can see here Q1, Q2, Q3 are in the same set in the previous row. So Q0, Q1, Q2 will be in the same set. And if we check for Q2 and Q3, Q2 and Q3 on getting input A, it goes to the state Q1, and on getting input B, it goes to the states Q2 and Q4. But as we see here, Q2 and Q4 are not in the same set in the previous row. So Q3 will not be in the given set of P1 row. So Q0, Q1, Q2 will form a single set, and Q3 will form a set, and Q4 will be as usual. Now, if we consider the row P2, we can check here Q0, Q1 on getting input A, it goes to states Q1, and Q0, Q1 on getting input B goes to the state Q2 and Q3. But as you see here, in P1 row, Q2 and Q3 are not in the same set. So, in P2 row, Q0 and Q1 will not be in the same set, they will be in different set. Now, we will check for Q2 to which set it belongs to. Now, we can see here Q0 and Q2 and getting input A, it goes to state Q1, and on getting input B, it goes to the state Q2. We can see here Q1 and Q2 present in the same state in the previous row. So Q0 and Q2 becomes a set, and Q1 will become another set, Q3 will become another set, Q4 as usual. So, and like this, if we continue the process, the P3 row will be like this, which is similar to P2. So we will stop this process at this moment. Now, this last row is the final states in the given minimized DFA. Now we can construct the final DFA using this states Q0, Q2, Q1, Q3, Q4. And the transitions is similar to DFA, and we can write using transition table. We can see here Q0, Q2 and getting Q0, Q2 and getting input A, it goes to state Q1, and input B, it goes to state Q2. So it is Q0 and Q2 and getting input A is going to Q1, and on getting input B, it is remaining in the state Q2. So likewise, we can draw remaining transitions also. And let us consider the example 2. Here, as we can see here, Q3 is unreachable from any transitions from the initial state. So Q3 will be removed at this moment. And with remaining states, we are drawing the transition table. We can see here the remaining states are Q0, Q0, Q1, and Q2. And Q3 is not written in the transition table because it is an unreachable state from the initial state. In step 3, we are dividing these states into two sets, one containing set of non-final states and another containing set of final states. Here, Q0 is initial state, that is non-final state. Q1 and Q2 are final states, so they are made into a set here. And when we will check for step 4, here Q1 and Q2 on getting input A, it is going to Q2 and Q1. Q1 and comma Q2 and getting input B, it is going to Q1, Q2. So these two form a set. So that is written in the P1 row. So we can see here P0 and P1 are similar. So we will stop the process at this moment. And the final row is the final number of states in the minimized DFA. The two states are Q0 and Q1, Q2. So the transitions can be made using the transition table mentioned in the step 2, and we can write the minimized DFA. Thank you.